Hello and welcome to Color Multimedia Enterprises. My name is Luke, also known as Tianeri, and in this tutorial we are going to be taking a look at different variable types in the Haxe programming language and be exploring how they work on different targets. Now, one of the things about Haxe is that because it generates code for different languages when you compile, it generates code from specific data types and it will generate specific types according to those types that you give Haxe. So that is dependent on a variety of things. First of all, the most basic of them is of course booleans, true or false, on or off switches, which is basically a value basically saying is it true, is it false. And then we've of course got things like integers, floats, we've also got a variety of other things, and we are going to be taking a look at each of them. Now, let us take a look first of all at integers. So si int, and let's just set it a value to 20. Okay, so first of all, let me provide you a bit of a tutorial on how we declare and set and assign variables in Haxe. First of all, var is required in order to declare that you are creating a variable. If you do not put var, then it is not considered anything. It is not considered declared as anything. So you have to start with var at least. You do not need an accessor. That will default to private, which means that it will belong to this class and only within the scope of this class. However, private can also be used in derived classes, which I'll get onto a bit later. Once you have said that you want to declare a variable, you then put the name of the variable and you can declare it or assign it. So this is a declaration because I've put a colon and b the data type that I want to give this variable, right? If I removed this and just simply assigned it, what the compiler will do is it will, at compile time, determine what that variable type actually is depending on the assignment. Because it is a number, it is going to automatically convert it to float. There is a concept in programming called lowest common denominator. Often, if a compiler cannot assume if it's a whole number or not, and also the compiler can't assume that this number will ever be a decimal number, it is going to find the lowest common denominator for this particular data type. Therefore, this data type is going to be a float, because at any point we could assign it to 20.6, right? But we're treating it as an integer because it's a whole number. However, if we want to specify that it is in fact going to be an integer, we declare it like that. So there's two parts or three parts to creating a variable. The first part is the declaration part, which is this bit here, and the assignment part, which is here. Certain targets such as Nico, JavaScript and others, these are static types, which means that variables can be assigned null. Null is basically an empty assignment. It assigns a variable as if there is nothing to it. It is completely null, there is nothing assigned to it, and it gets freed in memory automatically by the garbage collector if it's set to null, until of course at a time when you stop using it. Now there's also scopes to think about as well. Now I did mention it a little bit just now, I'm going to mention it again. Scope is the idea that you give a variable or function an accessor field. This is an accessor field, it's public. This means that when I create this class, main, anywhere else, I can then access that variable in the instance of that other variable, if that makes sense. I can also access it in this class, of course, because it belongs to this class. This static function, static is another accessor field. Static is available to the entire program. I can type in main.main and that will execute, but it will execute infinitely because we're within this function. So every time we go into this function, when the program starts up, it's going to assign SI to 20. Then we're executing this, which means that we're executing that, and it just keeps on going and going and going. And it will freeze or crash or something like that. So I'm not going to do that. Then what I'm going to do is I am going to make a variety of batch files in here that generates code for different targets. So we know that run.batch is for the C++ target. We're going to take a look at each individual target, except for Flash, because we can't take a look at Flash code, and we can't take a look at Nico code either because it generates bytecode. We can't actually reverse engineer that. So first of all, I am going to do run-cs.batch, and this is going to generate C# code. So just like before, we are going to just type in Haxe here, -cp, find the folder, the main entry point, and the file that we want to generate. So I am going to put it into bin/cs/ and the file that I want to generate. First of all, I want to go ahead and take a look on the haxe.org website just so that I know what I'm doing. Compiler usage sounds about right. So -cs, it is directory. Okay. So we will generate source code within that directory. I'm going to save that. And let's run that. So it should be fine. Oh, interesting. Okay, 2 seconds. Let's run the CMD. Actually, better idea. Open command prompt in this folder. And do run-cs. Cannot access SI and static function. Oh yes, of course. Because this, again, as I mentioned, scoping. You have to be a bit careful because this is, if I were to revert that back to public, I can't technically access SI in this because this is a static function and this is a member of main. While static functions, they are a member of main, but they are accessible everywhere. This SI is only accessible within main, which means we first have to instantiate main by creating a new version of it and then access that variable. So to make things a bit simpler, I'm just going to type in static just to resolve the issue that I had just now. Then run it again. And in order to build the CS target or C# target, you need to have installed hxcs, which is hxlib install hxcs, like that. I already have it installed, so I don't need to do it. So let's now take a look at that source code. It's in here, CS. It's got our CS project, so we can open it in Visual Studio, and it has generated our source code that we used. So let's take a look. There should be something in here. Maybe this one, I'm not 100% sure. Let's open this in here. Probably easier to read. So as you can see, we have a public static int si. So it has automatically so the Haxe compiler has detected it as an integer. It is going to assign it as an integer. It's going to generate that code, and then it's going to assign it 20, like that. That's interesting. It uses unchecked. That's weird. And one of the things about C# is that the unchecked keyword, what it does is it doesn't do any checks on variable size. So what it will do is it will take a look at, it will just simply assign the variable without actually checking the integer value. If that were checked, for example, and if, for example, I assigned it with 0 times ff, if that were checked, that would cause a Stack Overflow exception because it's too large for an integer. It needs to be a uint in order to assign any value higher than 32 bits, which in all purposes is basically that. If you were to type in that, this then needs to be a uint in order to work. But the unchecked keyword, because that's there, that will still pass. That will still be accepted, but it will just, the C# compiler will automatically, I'm not sure if infer is the correct word, but it will assume that this integer is essentially a uint at that point. And I know this because I come from a C# background. So if we wanted to, we could build that project right now. So what we would do, well, it's already built. So what I could instead do is assign it with another value. Like that, for example. Let's run it again. Everything is fine so far. So now, what we can do, I meant to say yes, not no. Let's go back into src, let's go back into main, let's drag that over. So, but now, as you can see, it's -1 because when the Haxe compiler checked the value against the integer variable, it was too high. It would cause a Stack Overflow exception. So in order to make sure that that doesn't happen, we can make this a uint instead, and it will actually assign the value correctly. So let's try that again. Yes. Oh, that's weird. Why would it do that for? I think there might be a bug in Haxe. In HXCS maybe. It should not be doing that. It should not be doing that. The reason why that would work is because this is a uint. It should work, but it doesn't for some reason. I really don't know why. That is really odd. Well, we're going to check different targets anyway. So what we could do is just type in run to build the C++ target and take a look at the source code for that. Generated code, which would be of course inside main.cpp. And it's good to know these things, because when you take a look at the source, the generated source, you get to know how the Haxe compiler generates and returns its results. Now this is taking a while to build for some reason, and I really don't know why. Why are you taking so long? Is there a reason you're taking so long? Hello? Are you going to crash? um. I do not like this. Why aren't you going? Work. Oh dear. Oh my god, seriously, what the hell is wrong with you? Work! Jesus Christ. It's just stuck. Why is it doing this? We could probably take a look at main.cpp anyway. While it's messing about. Oh, it finally works. Oh, that is so weird. Why did it take so long? But anyway, let's take a look at the generated source code. See what's going on. That is -1 again. What? Wait. That is a uint. Why does it do that for? I really don't know. Huh. That's interesting, because as I was carrying on with one of my libraries, OpenFLGUI, I was able to get Bitwise Operations working, which would go up to 32-bit integers, or unsigned integer value. Wait, that's not supposed to be a integer, that's supposed to be a uint. What the hell? Does it generate it correctly? SRC. Could just reload it, I suppose. Nope. Still there. Why would you do that? Seriously, why? That is so weird. Huh. It's doing it in both C++ and C#. Maybe there's something wrong going on there. Yeah, I'm not 100% sure what's going on there. This is supposed to be a unsigned integer. This is supposed to be a value that can be stored inside a unsigned integer. Otherwise, we would have got an error, I presume. No, it wouldn't be a compile time error. And by the way, just so that you are aware, compile time means anything that everything that the compiler does to check to see if everything's correct. So if this is not correct, which it is, obviously, otherwise it wouldn't have compiled, then that is a compile time error, and you would need to fix it before you go in. Runtime error is something that happens during which you launch your application and start playing around with things. So yes, I'm not 100% sure what's going on there. What I can teach you, however, because obviously for whatever reason the Haxe compiler is not having a good day today, what I'm going to do is show you Bitwise Operations, which is going to be a part of this tutorial series in order to make sure that we get things working. So what I'm going to do is I am going to say SI. I'm going to shift down the bits by 16, and we're going to read it. Now what I'm going to do is I'm going to trace I, and then we are going to just say sys dot read line. So let's build that. Oh, maybe it's get car. I think I'm confusing myself. Because if you remember in the previous tutorial, we were taking a look at our inputs and being able to communicate with the command line. So that is 255. Why, you might ask? This value here, FF, results in the integer value 255, right? Now because we shifted this value here by 16 times to the left, right? So every value from the let me get paint on that just to make it a bit easier to tell you what I'm talking about. Or maybe just paint. I'll just get paint up. Why not? It works faster. So we have, right, a variety of values that go from, I'm going to save it. So from here we've got 0, right? This is the 0th value. And then we've also got our 32nd value at the end here. So the FF that we saw in our program looked something like this. So F was here. Let's make this a bit bigger so that you can see. So F. Oh. F like that, right? So we've got F and F here. We've got 0, 0, 0, 0, and 0, 0, right? Now, well, technically this is 24. This is the 24th bit because we shifted it down 16 times. So basically what the CPU will do is it will read the value, right, and it is going to shift down 16 times. So it's going to go down here in that direction, right? It's going to go down in that direction until it gets to the bottom 16 times. Now because this is hexadecimal values, each digit is worth 4 bits, right? Is that right? Yeah. Yes, that's correct. 4 bits. And then thus FF is going, so this value, so FF is going to go down 16 times. So this is 8, that is 8, so that's 16. So it will be shifted down to result essentially in that, right? Then it's going to read, I apologise for the background noise, then it's going to read that value instead of it reading it like that, and that will result in 255. What if we wanted to actually add another value? Let's say here, for example. That's also fairly easy to do. So what we can do is we essentially create a mask. So what I'm going to do is var mask, so it as if it's so essentially it's like saying green, because obviously the middle value is going to be green. Wow, that's loud. So green, let's say that's 0FF, right? So now what I want to do is I want to add that green value into SI. So I know that green is going to be in the middle, so I need to shift the value, this value, left 8 times, sorry, in order to result in that. But obviously it won't do that because it's going to equal it. So first of all I need to OR it first, so that it results in that instead. Right. So what I'm going to do is I am going to trace instead SI, and I'm going to get rid of this. So let's imagine we didn't do that operation, so I'm just going to comment that out. Don't think so. Yeah, I'm going to comment that out. I'm going to build it. Build failed. Oh, stop running it. That's why. Right. So now when we go in, open. So this is the value as it. Oh, of course. Hang on. We don't want it like that because obviously it doesn't. So let's rebuild that. Take a look at the value, then do the change. So let's go back in here, open it. Okay, so this is the value 167,11680. So that is 167,11680. Right, that's that value there. Now if I were to remove this comment, save it, rebuild, obviously close this down first before we decide to go ahead and do that. Okay, not that one. Build it once again. Now as you can see, the value is slightly higher. So that was the value before, this is the value now, because we or shifted the value of green, which is FF, so 255, in 8 times to the left. So that resulted in what we had before, which is this one here. And just to make sure that that is in fact correct, I am going to comment this out, make a record of that value, which was 16776960. 960. Right, I believe that's right. Yep. So let's remove that. Let's now set that value to that and actually show you the result. Run it. And when we go back in, as you can see, that is in fact the value of FFFF00. So that is what the value was when we shifted green 8 times to the left. So I hope that has made some sense to you, hopefully. So that was a bit about Bitwise Operations. In the next tutorial, I am going to take a look at a few more values before we decide to then go a bit further into general scoping and also creating classes. So thank you very much for watching. I hope you enjoyed, and I will see you next time.